So up until now, all of the rocks that we've been targeting for our thermochronology and geochronology sample have been igneous and metamorphic rocks. And that's usually what people target. Sedimentary sequences have a lot of potential, but they always have a few difficulties associated with them. They can be really powerful for you because what they're often preserving are rocks that are no longer where they used to be. So for instance, we're standing here on an outcrop of the Humboldt Formation, looking at a conglomeratic layer, and all of the rocks that we see here used to be on top of a mountain somewhere and got eroded down. So if we hiked all the way up to sample these, we wouldn't find them. This is where they are. So the complication with using sedimentary rocks for geo or thermochronology comes in with how you interpret and analyze the data. Typically, when we're going to analyze and interpret thermochronology from a particular sample, we're going to be looking at data from multiple individual crystals or a little pile of crystals that we put together and analyze together. And in igneous and metamorphic rocks, that works well, because when you sample a big chunk of igneous or metamorphic rock, you know that that has been a big chunk of rock that's been together and shared a common history for millions and millions of years. But in sedimentary rocks, you can't assume that. Sometimes, if you're looking at sandstones or shales, the material that is being fed into the basin where the sedimentary rock is accumulating could come from an enormous drainage basin, hundreds and hundreds of square miles in some instances. So if I wanted to pick out 5 or 6 individual crystals and analyze them and interpret them, I couldn't assume that they've actually shared their whole lifespan together, or even a large part of their lifespan. They could be representing completely different thermal histories that are not related to each other at all. They just happen to end up living in the same place now. What is exciting for us then is when we find samples like this. So like I said, this is part of the Humboldt Formation. It's a Miocene to younger conglomerate. And what we have preserved in here, as you can see here, is an enormous chunk, a big hunkin' chunk of some sort of granodiorite granitic rock. I'm not entirely sure where it's from right now, but I know if I actually sample this big clast, that all of the minerals inside here have all shared the same thermal history. And even though might be different from this clast and this clast and this clast and all the other ones around here, everything in this clast has shared the same thermal history, which means that I can actually use all of the tools available to me in thermochronology and reconstruct fairly detailed thermal histories of this one particular part of the rock.